Building codes are a part of life, and whether you're a professional builder or a contractor, or you're a homeowner who's looking to improve or build for yourself, you should understand how these things work. And I realize that I've never actually given a full tour through the ASHRAE 62.2 standard. The 2022 version has some interesting things in it, and I wanted to just kind of give you a brief tour through a lot of this stuff. I've highlighted just certain parts of this. So you can see here on the left, we got the table of contents. And this is all the different things that they're imagining that this should entail. And there are some surprises in here that we'll get to. So over here in the foreword, you can see that it's just talking in 62.2 is about residential occupancies that are non-transient. That's this first bit right here. Non-transient means less than 30 days of occupancy. That could be a short-term rental. So essentially what that means is if you've got like an Airbnb or a hotel, for example, this does not apply to that. What does apply to that would be the next question. And if it's a hotel, then it would be a commercial code. But like for these, I'm kind of concerned about the whole vacation rental, like who's governing how healthy these spaces are, because I've stayed in some that are pretty crazy. I'm actually in one right now that is wonderful, and I'm actually here to test it. So that was like an extra special thing to know that there's like people out there who are really trying to do this right. But this standard is built to try and help people who own places like this or who own homes or who are building homes to do this right. Dwelling unit ventilation is intended to dilute the unavoidable contaminant emissions from people, materials, and background processes. That is beautiful to hear, because I think that a lot of people think that if we pay attention to the materials, we select low VOC paints, we do all the things, and you do all the homework, that you're going to have a very clean house. Absolutely not true. You cannot avoid poisoning yourself in a home, because we, frankly, are pollutants ourselves. So if you're going to live in the home, or if somebody's going to live there, it's going to be a problem. Right here it says local mechanical exhaust is intended to remove contaminants from locations such as kitchens and bathrooms that, because of their design function, are going to be especially polluted places. So that's why, for example, I'm always kind of try and push people in more airtight scenarios to pull the stale air that's going to get thrown away from the kitchens and the bathrooms, because it makes the most sense rather than just pulling it from the return side of your air handler in a very much simpler ERV setup. Standard 62.2 does not address specific pollutant concentration levels. They're not trying to cure COVID. They're not trying to solve formaldehyde specifically or ozone specifically. They're trying to say that if you follow these guidelines, you're going to be able to blanket all the pollutants that you might have in a space. Down here, I especially like that they are talking about chemical, physical, and biological pollutants. That is the three that we're always talking about on this channel, which home chem kind of opened us up to. So physics is what building science has generally classically been about. Chemistry and microbiology are also super important, and they're actually specifically building into the standard now, which I love. So in purple here, while acceptable indoor air quality is the goal of this standard, it will not necessarily be achieved even if all the requirements are met. They are putting that right up at the front. And I'm going to read all 5 of these things here. So A, because of the diversity of sources and contaminants in indoor air and the range of susceptibility in the population. And that last part is really tricky. That's where builders and contractors are going to get kind of more in trouble with people who are coming to them who have specific environmental sensitivities, or what's called multiple chemical sensitivity. These are people who have been activated by some exposure to mold or some other chemical that makes them more sensitive to what's in their environment. So this is saying like, hey, if you're one of those people, you might need something a little bit more hardcore than what we're recommending here. B, because of many other factors that may affect occupant perception and acceptance of indoor air quality, such as air temperature, humidity, noise, lighting, and psychological stress, none of which is accounted for in this standard. And we should be thinking about this. That's why like going to the standards is important, but also knowing how to think outside the box is very useful too. C, if the ambient air is unacceptable and this air is brought into the building, and that ambient means outside air. So like, for example, a train wreck with chemical spill or wildfire outside. If you bring that air in without first being cleaned, then you're not going to be happy. And what it says then is ambient outdoor air cleaning is not required by this standard. So in those scenarios, you're going to get in trouble. D, if the system or systems are not operated and maintained as designed. And that's a big one for homeowners and for renters. And for the renters, it's not necessarily totally your responsibility. Maybe there's a closet that's locked that you're not supposed to go into that has the filter in it or whatever it is. And they say, don't touch the HVAC equipment. I do that. But then they don't show up. They're breaking this standard. So you need to make sure to stay on your landlord about that. And lastly, when high polluting events occur, like I mentioned, the wildfire smoke and the train derailment kind of a scenario, battery facility explosions, things like that, that's all going to be pretty bad. So none of that is covered by this standard. Last thing on this is acceptable indoor air quality. I like that they next have a definitions page, and I'm just going to show you that. You could pause and read through all the definitions if you want to. So air toward which a substantial majority of occupants express no dissatisfaction with respect to odor and sensory irritation. And by the way, just to put a pin in that for a second, they're not saying this is air that people are happy with. They're saying this is air that people are not complaining about. And that's a really important distinction, because you won't, if you say, hey, do you like the air in my house? I just built this perfect little house and like, it's great. And people say, yeah, weirdo. You know, if they're not complaining, that means they're happy, basically, is what this is trying to say. And which there are not likely to be contaminants at concentrations that are known to pose a health risk. So that then is that piece that we were talking about selecting the chemicals that go into your home carefully. Don't be a freak about it. Don't make yourself miserable. But like, you know, don't decorate your home with like gas station signs from the 1940s that 100% have lead in them. They are made of lead and they have lead paint on them. Like, don't do that. So things like that are important. By the way, I'm going to just real quick mention that you can get access to all of these standards. I'm going to drag my face over here at this website, which I'm linking in the description in this video. And you can read through for free all of the standards. They're not going to let you print it, but you can read them. And so 62.2 2022 is the one that's right here that you would just click on and it'll open in a new window. So I think that should be useful. Make sure that you go and read that if you want to. Okay, so we go blah, 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 blah through all the definitions. You can see non-transient right here. Occupancy of more than 30 days is non-transient. Transient would be less than 30 days. And then it goes through all of the abbreviations that they're going to talk about in this. So I just wanted to make sure that you knew that was there. So let's go over here and look at these. Dwelling unit ventilation. This is the beginning of what generally, if somebody says ASHRAE 62.2, they're talking about this, which is the fresh air that needs to come in from outside to dilute the contaminants that we just talked about. There are two calculations right up here at the top. And what these are, Q is flow. Q is a symbol that means flow. So the total flow needs to be 3 CFM per 100 square feet plus 7.5 CFM for each person. And we count people as number of bedrooms plus 1. So 3-bedroom house, 4 people. That would be 30 CFM for the people. It's a 2,000 square foot house. There are 20 hundreds in that. So 20 times 3 is 60 CFM plus the 30. So 90 would be the calculation for this. That might be a little high. So there's another way down below where we actually build in the blower door test. But first, let's just talk about these exceptions. Dwelling unit mechanical ventilation systems are not required if the authority having jurisdiction, AHJ, says, and this is a guy who's from your code department, your building department locally, and he might have been a carpenter in his previous career. They are generally overworked and underpaid and understaffed, and they don't necessarily have to own the code book. They don't have to own this code to be able to enforce it. And this code is going to be cited by other codes, and I'm going to talk more about this in a minute. So they should know what's in these, but they often don't, and that's why I'm telling you. So if the code guy says that window operation is locally permissible, it's okay, just open a window. How many times have you heard that? And provided that at least one of the following conditions is met. And this is the big catch. Number 1, the building has no mechanical cooling and is in climate zone 1 or 2 of the map. That means a shed, basically. And also, the building is thermally conditioned for human occupancy for less than 876 hours per year. How did they pick that number? That's a weird number. That's 1/10 of the year. So there are 8,760 hours total in a year. They picked 1/10. That's basically like 36 days straight. If you were to be in there for 36 days straight, it wouldn't need ventilation. Or as far as like an 8-hour workday kind of thing, it would be like 110 8-hour workdays in this shed. So just FYI, and if you're working in there, it should be under OSHA, and there should be other commercial codes that, again, this is about residential. So what they're trying to say is like, hey, there are instances where it would be ridiculous to have a ventilation system in here. It's just going to drive cost up. There's no people in here. There's no health risk, blah, blah, blah. So infiltration credit here in yellow. If a blower door test has been performed, this is my quick plug, always run a blower door test. It's the most important test you could possibly run on a home. Don't skip it, just do it. Then you can use the infiltration, the air leakage that's coming into the home as a credit against this, what we calculated a minute ago is in a 2,000 square foot house with 3 bedrooms, 90 CFM. You can come down here and you can subtract it out. So that's what this here is for. And I actually detail this in a video that's separate from this. I go through how this calculation works so that you can know how to do it on the back of a napkin. Be very impressive to your friends. Not your friends, but your clients probably. So the exception here is where the flow that's required is less than or equal to 15 CFM. Skip it. I think that's a mistake. So I lived for 5 years in a 200 square foot tiny home on wheels called the Tiny Lab. There's a playlist. I'm linking it on screen right now if you want to see more about that we built, and it's the highest performance tiny house on wheels in the world. Very, very cool, blah, blah, blah. The dilution rate in there was, if you only put one person in that house, which is like would be reasonable for us, it was 2 adults, 2 cats, and 2 babies by the time we were done with it. It was 30 CFM. But you might consider, if you had one person in there and it's only 200 square feet, that 15 CFM, at which point I don't dilute the air at all. That would be a mistake. First thing that's going to happen in that case is you're going to use a bath fan as your ventilation source. And that would be a whole nightmare for pressure reasons, which if you've seen anything about that tiny house, then you know what I'm talking about. Okay, I have a different shirt on. Don't look at me, look at this. I forgot this when I was initially recording this. This page shows the ventilation table. If you don't know the blower door test, you just use this thing, which is like 3 bedrooms, 2,000 square foot house. You're looking at 100 CFM, 105 of ventilation. But if you want to be able to subtract out what is coming through ventilation, what is coming from air leakage, infiltration through the enclosure accidentally, then you can use this little equation down here. By the way, this is in CFM and in liters per second. It's just American, Canadian, or other metric. So this one down here, there's a calculator for this. It's called RedCalc. Go use it. It's a lot easier than trying to figure this out and looking all this stuff up. Down here, you can see that the ventilation rate reduction for particle filtration means that we can actually now also credit not just the air leakage that's coming from outside, but the filter effectiveness for the little aquarium pump that we have inside of our little aquarium that we're, if you can imagine an aquarium, you turn off the pump for a couple hours, the water starts to turn green. That circulation pump with the filter in it is what we are using a filter to grab. You don't need to just have a hose that's introducing water from the river all the time into an aquarium and then dumping out water. You could just have this aquarium pump run around. So that's what this is for the filtration. Now here, what's really interesting about this is that this standard, the ASHRAE 622 now requires MERV 13 minimum filtration. You can take credit for it over here, but you have to put in a MERV 13 filter in your HVAC system. Here's the way this breaks down. MERV 11 has a filtration factor of 4.3. You can see that 4.3 here is associated with a particle size efficiency of greater than 1 micron of 65%. So it'll grab 65% of stuff that's 1 micron or bigger. What we're generally really worried about is smaller stuff, and it grabs 0% of those things. You need to get up to a MERV 13, which is right here, MERV 13,
2.1 filtration factor to start grabbing 25% of small particles, 85% of big particles. What's cool about MERV 16, aside from the fact that it's just shy of HEPA being MERV 17, is that it's grabbing 95% of big and small particles. So they're saying basically you have to have a MERV 11 filter built into this. This is going to kind of piss a lot of HVAC installers off because they're all under the impression that if you put in a MERV 11, you're talking about a 1-inch filter that I got from Home Depot, because Home Depot doesn't carry any filters that actually could achieve this and not choke your system. So essentially we need a whole bunch of suppliers, unless we're all going to order this stuff online, which is great. That's what I do all day long. I'd never go shopping for a filter in real life because you're not going to find the thing you're looking for. So anyway, I just want to make sure that this page got also included in this because it's important.
So up here, we're still in dilution air, right? In figuring out how much air we need to bring in. So the system type is important. What it says here, this is the first prohibition here. Exhaust-only ventilation systems, meaning using bath fans 24/7 to draw air out of the unit, is not permitted for new attached dwelling units that open directly to an enclosed corridor. Okay, what that means is multifamily building, right, where you got apartments, and there's a central corridor that is interior, not outdoor. You can't use bath fans as your 24/7 because what they're trying to do is prohibit air from circulating between the units through the corridor, using the corridor as a way to do that. And by the way, that's like, as far as I understand this, and you guys feel free to comment if you're an engineer watching this, that is a very common way to ventilate multifamily buildings, is to use what's called a hallway plenum or a hallway supply system, where you supply fresh air to the hallway, then it gets drawn under the air by the exhaust systems in the apartments. Hotels are done that way too. This is new buildings only. Outdoor air ducts connected to the return side of an air handler, that's supply-only ventilation, shall be permitted as supply ventilation if manufacturer requirements for return air temperature are met. Generally, what that means is you got to have that duct that comes in be at least 10 linear feet away from the air handler itself, because what you don't want is for freezing cold air to come in from outside and immediately hit your heat exchanger and make the thing freak out. It'll result in like shrinkage and expansion of the heat exchanger, and in a furnace that could result in cracking the heat exchanger, which means that you're now bleeding carbon monoxide into your air. Okay, nicer stuff. Airflow measurement. And by the way, codes started incorporating testing and measurement in the 2009 IECC. So this is another really great thing for testing professionals and for people who are like interested in proof. They're building the fact that you have to measure this thing before you say, okay, it's good. You can't just install it, you got to test it. The mechanical ventilation airflows required by this section shall be measured according to the ventilation equipment manufacturer installation instructions, or by using a flow hood, a flow grid, or other airflow measuring device at the mechanical ventilation system's termination grills or in the connected ventilation ducts. And they say that you have to test both the incoming and the outgoing, and you have to test it in all modes. So you got to test it at low speed, at medium speed, high speed kind of thing. That's really helpful. So I think that's going to help a lot of homeowners, because a lot of times these things get installed and no one is there to actually test them. The secondary question to that is, who is going to test that? I have a list, if you're not aware of it, that's scientific HVAC installers. I'm linking it on screen right now. If you are an HVAC installer and you believe in science and math and testing, go sign up and be on that list. It's free, and it's free to look at it too. But we need more people who can do testing. And I wrote a book to be able to get people more up to speed about this. There's lots of people out there doing trainings for this. There's lots of videos you can find on this YouTube channel that show you how to do this testing. We gotta find more ways to encourage testing among professionals. Controls. An on-off switch that is readily accessible has to be available. This is good and bad. So number one, it's important they put it in there because you need to be able to service this fan. You can't just install a fan, hardwire it, and be like, you can only shut this off at the circuit breaker. Most homeowners are not going to know how to do that. Also, is the circuit breaker just for that one fan? That would be crazy. So it's good, but it's also if you label it main ventilation shutoff, it's totally possible that if you install something that's noisy, which again, noise is not covered by the standard, people are going to find a way to shut it off. They don't like it. It's annoying. So now I shut it off, and now I don't have any ventilation, and all the things that are in the standard are completely moot, because even all the testing that you did after you installed it, that doesn't matter either, because now it's off. It's just not doing anything. So you got to make sure that it's quiet stuff. For multifamily dwelling units, the on-off control shall not be required to be readily accessible to the dwelling unit. It can be for the super or the landlord, right, at that point. And that, I think, is, it'd be nice to have it not be so readily accessible because of that exact thing. Or like in the case of people who are hard of hearing and they can't tell, and the label falls off. You could just put a sticker on there that says ventilation shut off, and then it falls off, or a kid peels it off. And then it's like, I don't hear any difference. I'm going to leave it off because I want to save energy. Okay. The other thing is that they're timing this. They're thinking of time scales that are not one day. And this is good because it turns out when you look into the really deep chemistry of this, and we have a playlist called PhD level indoor air chemistry. I'm linking it on screen right now, if I haven't run out of links that I can use, that as soon as you turn off the dilution or the filtration or whatever it is, the building now starts emanating it in, and whatever healthy levels you were at on indoor air quality spike right back up into a less desirable place, a place where people might complain more. So they're saying that the consecutive period that you need to be ventilating for isn't one day. You don't need to like supply 90 CFM for every minute of this house, but I could just do 18,000 CFM for like half an hour at the beginning of the day and then just coast on that for the rest of the day. You can't do that. You got to do it every 3 hours as a reset. So we have to be ventilating within a 3-hour period. That 90 CFM times 60 minutes times 3 hours. If you wanted to fill up 3 hours, you could do that, give that amount of cubic feet of air, and then you could hands off for 3 hours, and then you have to come back and do more. Okay, over here, we can see that we've got a couple tables. So demand-controlled local exhaust airflow rates. This is when you need it. You have a switch in the kitchen exhaust hood or in the bathroom fan, and you turn it on. You can either do a 100 CFM exhaust hood in the kitchen, which I don't know why this is in here. That seems really, that doesn't sound like a lot. I don't know how well that would work. I don't know how much research there is on that. And I'll ask Brett Singer, actually, who might be on this committee that wrote this thing. Other kitchen exhaust fans, including downdraft, 300. For those of you who were thinking of downdraft, that is what the scientists are thinking is like, oh, okay, if you're going to use an updraft, 100. If you're using downdraft, you got to have it be 3 times as powerful. Downdraft is dumb because warm air wants to go up. So just please try to find a way to redesign your kitchen. It's going to make your life way better. Or a capacity of 5 ACH. And this is where this is a little bit weird. I don't know why they would put that in there because that seems like it's cheating it. Down here, you can see that the continuous, we could have be 5 ACH. That would be 75 CFM for a 100 square foot kitchen with 9-foot ceilings. 75 CFM continuous from the kitchen. That's a lot for continuous. Never shuts off. They're saying a demand-controlled downdraft, 75 CFM, that's less than the updraft. So I think that's a mistake, but I don't know how it got past the committee. Like there's so many subcommittees and committees, they just talk about this nonstop, and they're all engineers. I'm not an engineer, I'm a dummy compared, but like that seems like a mistake. Non-enclosed kitchen, vented range hood, 100 CFM, right? Again, or other kitchen exhaust, excluding downdraft, 300. So if it's enclosed, you can do this little exception of the 5 ACH, which again, for a 100 square foot, 9-foot ceiling kitchen is 75 CFM. Seems weird. Bathroom, 50 CFM bath fan. Okay. Continuous in the bathroom, 20 CFM. And again, this enclosed kitchen continuous, 75 CFM. That's a lot to take out of the kitchen. I don't recommend that. I recommend that you should, first of all, don't put kitchen exhaust fumes through an ERV core because it'll gum it up. And also you'll have, like passive house people tried to do this for a couple decades, I think, to do recirculating kitchen exhausts with a filter in it, which does not grab tiny particles. And tiny particles are a key ingredient in cooking fumes. Every time you warm up a surface, little particles emanate off of it, and that's what cooking is. So anyway, I would just skip this and do a kitchen exhaust hood, and don't do 100 CFM. Do more than that. But anyway, prescriptive duct sizing. So this is for the next page, but they're saying that if you're gonna just follow our instructions, then you're gonna have a 100 CFM fan. You got to use a 5-inch rigid duct or a 6-inch flexible duct. If you're going to put 200 CFM, this is a microwave, 200 CFM exhaust hood in, you got to use a 7-inch or an 8-inch round. Finding 7-inch round rigid duct is kind of difficult, so you're going to probably use an 8. That's a lot. I ducted my 400 CFM kitchen exhaust hood with an 8. This is saying with a 10, that's 50% bigger than an 8. An 8 is basically 100% bigger than a 6. So these are way oversized. And the reason that they're doing it is because they want you to hit 0.25 inches of water column static pressure max. Okay, we'll call back to that in a second here. Let's get into local exhaust. So this is for specific mechanical exhaust that's in spots, which I don't know exactly why. It's hard because it's like all one big topic, but they are having to break it down. These things up here, the local exhaust, technically fits down here. I think they're trying to fit it on the same page, but it looks like it's before. Okay, so in local mechanical exhaust, you can see that over here, we have airflow measurement. You can't just put in a bath fan and a kitchen exhaust hood. You got to test them. Testing a kitchen exhaust hood is actually kind of difficult. You're going to need cardboard, and you're going to need to use cutting, and you're going to need to use tape, and you're going to need to build a little jig for yourself to test with, because these kitchen exhaust hoods are not shaped well for us to be able to test them. So that takes time. That's like half an hour of work just to test the kitchen exhaust hood, and plus this very expensive tool. Okay, exception can be made if you use that prescriptive table that I just showed you. You don't have to test it if you oversize the duct like crazy, like I just showed you, right? So then we can not worry about it. I will say I have tested, and I've got videos of this on this channel, I've tested fans that are actually backwards. Somehow they were either installed in the factory backwards accidentally, which is weird, or they were somehow messed with in the field and they run backwards. So I wouldn't skip the testing. Other requirements. Okay, we're in the tail end of this discussion. Adjacent spaces and transfer air. This is like miscellaneous stuff that we're getting into here. Dwelling unit boundary wall, ceiling, and floor penetration shall be sealed. Okay, this is very, very important for multifamily buildings, but it doesn't directly have to do with ventilation. So they're kind of stepping outside their lane at this point. And the interesting thing there is that you've got codes. What happens is the International Code Council, ICC, releases codes. They release International Energy Conservation Codes, which is where a lot of the insulation and the blower door and the duct tightness stuff lives. International Residential Codes, which is where ventilation is called out. If you're going to build tighter than 5 ACH 50, you got to follow this standard. But then states amend those international codes. It's a USA-based thing. They'll amend them. And they'll say, oh, we're going to strip out the blower door test requirement, for example. And plenty of states do that dumbly. And the thing is that they're going to not amend this one because they didn't even know. This is a cited sub code that you have to meet. You have to meet ASHRAE 62.2 in the ventilation way over there. And then they'd be like, oh, builders don't want to air seal stuff, so we don't have to make them do that. But you're also requiring that they meet ASHRAE 62.2, and this is required within ASHRAE 62.2 now. So we're building like this network where you can't avoid this stuff. You got to get good at air sealing. That's very interesting. Second thing over here is space conditioning systems. This is in Manual J and Manual S and D. So HVAC systems that are include air handlers or ducts located outside the dwelling unit boundary, like in the garage, for example, Florida, shall have a total air leakage of no more than 6% of total fan airflow when measured at 25 pascals or 0.1 inch of water column using the California Building Energy Efficiency Standards. blah, 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 blah. Okay, so what's interesting about that is that this is called out in the IECC, the duct tightness testing thing. And the duct tightness testing started at 12 CFM per 100 square feet, or what we call 12%. In this case, it's talking about a percentage of the air handler capacity. So think about this. You install a 2-ton air handler. That's 800 CFM. If you were only going to leak 6% of the total fan airflow, so 1% of 800 is 8. 8 times 6 is 48 CFM. So you have to leak less than 50 CFM on this duct system. And the smaller the system is, like if you're installing a 1.5 ton system, now it's only 600 CFM. So now you're limited to 36 CFM of leakage. All this to say, this code is building requirements for other requirements into the ventilation code, which is not spelled out exactly in the code that the states adopt, which is then amended. So just if you're a legal-minded person, keep that in mind, because that's very interesting. Here is something that I actually find problematic. So where atmospherically vented combustion appliances or solid fuel burning appliances, like a fireplace, are located inside the dwelling unit boundary, the total net exhaust airflow of the 2 biggest exhaust fans, not including a whole house fan, which they're calling a summer cooling fan, intended to be operated in conjunction with windows, blah, blah, blah. So not counting a whole house fan, but like bath fans, kitchen exhaust is mainly what they're talking about, or dryer, more likely, and kitchen exhaust, shall not exceed 15 CFM per 100 square feet of floor area. Let's just do the thought experiment real quick. So if you've got a 2,000 square foot house, the 15 CFM per 100 square feet, there's 20 hundreds in 2,000. So 20 times 15 is 300 CFM. So that's 150 CFM dryer. Plus, if you've got a microwave that's vented outside over your cooktop, that's 200 CFM. That's 350 CFM. We do exceed this. Okay, so at that point, this is going to be a problematic. So you're going to need to follow the other things that they're recommending here. Here's the problem with this. So my tiny house, for example, which I already mentioned, is 200 square feet. So in 200, there's only 2 hundreds. So I would be allowed 30 CFM of exhaust. And that's weird. If I have a house that's very, very tall, like got huge ceilings, 10-foot, 15-foot ceilings in some places, but it's small, it's still 2,000 square feet, and it's built very leaky, or it's built very tight. The point here is that like how tight the home is built, I think is very important, because as I just mentioned, they're amending these codes. So Florida, for example, is right now at 7 ACH 50. You can build a house between 3 ACH 50 and 7 ACH 50. That's a huge window, and that's really leaky house. That house is not going to have a problem with 300 CFM of exhaust. If it's this kind of a setup. If it's a very airtight house, it'll have a problem way below 300 CFM. You could have a problem way down at 100 CFM or even 50 CFM. And generally what they're kind of looking at is the most dangerous atmospheric vented appliances are an atmospheric drift water heater and a fireplace, open hearth fireplace. Both of those 2 pascals is all it really takes to start screwing them up, because the only thing that's getting the combustion gases to go outside is buoyancy. Okay, so I'll get off my soapbox of that for a minute here. Habitable spaces. Each habitable space, which is places where you spend time. This was in the definitions if you want to go back. But this is places like bedrooms, obviously, living rooms also, shall be provided with ventilation openings with an operable area of not less than 4% of the total floor area. So for example, 100 square foot bedroom, 10 by 10 bedroom, is 4 square foot window is going to need to be in there. And by the way, down here, I've drawn this arrow. Ventilation openings count as operable windows, operable skylights, through wall inlets, window air inlets. Those are called like trickle vents or similar devices, blah, 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 that can be operated by the occupants. This is a new one. It wasn't always the case that you needed to be able to open the windows. And like a lot of times in my practice, I'm recommending fixed windows most of the time. You're going to have to put something that's operable in these, and that's built into the ventilation code. Even though we're in a very airtight high performance house, you're not really using windows as ventilation sources, but they want the option. Here, you can see air inlets need to be located 10 feet away from each other. So like ERV is really what we're talking about, right? Or if you've got a supply air inlet, you can't put it within 10 feet of a dryer exhaust, a car that's idling, garage, things that are going to be gross. You don't want those coming back inside through your inlet. But down here it says where combined exhaust intake termination. This is called a concentric vent. So one hole in the wall, and you've got the air coming in and the air going out, going through that one fitting. If you're going to use that, then that's okay. And we're going to make sure that the manufacturer has tested and shown that there's only a 10% backwash with their fitting. I think that's, I don't know. That sounds like the manufacturers who sit on this committee 100%, which include great companies, by the way. Panasonic has a concentric vent. Broan has a concentric vent, and I like them, but they will tell you too, if you're like, hey, which is better, concentric vent or two vents that are more than 10 feet away from each other? Yeah, totally. Just separate them. So this is kind of like a commercial, like there's a lot of production builders out there who are like, I'm not going to put two holes in the wall because it costs twice as much and we got to save pennies. So last thing here, minimum filtration. This is, I think it's going to be more and more required, but minimum filtration from outdoor air is required to be MERV 6 minimum. What this means is my tiny house, for example, has a passive vent that opens in the wall when you turn on the kitchen exhaust hood. And I talk about this on this channel a lot. There's two ways to do makeup air: passive makeup air, active makeup air. Active has a fan. So if you're going to open up a hole in the wall and allow pressure relief to happen, makeup air in your kitchen, you have to put a filter on that thing. And there's not a lot of options for us that are not huge. So you got to think about this because we want to be able to follow the standard. Obviously, this is important. Last thing is that filter pressure drop needs to be established, like predicted, by going into tables and looking at that stuff. And then you need to make sure that we've got the label on it that says what the design airflow and then like how often it needs to be changed out. And maintenance, of course, is a big thing throughout this. So air moving equipment, last thing. I believe, no, it's not. I've got two more little pages for you here. Again, like I appreciate your patience on this. I think this is interesting. Carbon monoxide alarms in the ventilation standard. Cool. Air moving equipment. So ratings, airflow and sound ratings shall be provided for ventilation devices and equipment serving individual dwelling units. They should be provided in accordance to HVI, which is the Home Ventilation Institute, or Home Ventilating Institute, excuse me, or equivalent, and blah, 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 blah. So that's good that like we have this built into this. And they said up front that they weren't really thinking about noise, but sound rating for fans. Ventilation shall be rated for sound at no less than the minimum airflow rate required by this standard. And that is important because a lot of the manufacturers will tell you what the noise is at the lowest speed the fan can run, not at the target that you're going to want it. So the manufacturers are now going to have to test this and publish their zone ratings at all of the settings, at low, medium, and high, so that you can be like, oh, at medium, which is what I need, this is what the sound is going to be. And what it says is that if it's continuous, it's got to be rated at a max of 1 zone. And then let's see here, demand controlled shall be rated at a max of 3 zones. So that's like kitchen exhaust, bath fans, right? The zones is a way of measuring like human perception of noise. So 3 zones, I believe, is 3 times as loud as 1 zone. 1 zone is very, very quiet. In fact, a lot of people would say that 1 zone is not what I want in my bathroom because I like to have a little bit of noise to cover my bathroom sounds. You can get, like in Japan, they've got little noise-making machines that you put in there, like a little sound machine. So, because it's like, yeah, making noise means the fan is running inefficiently. Okay. Exception, fans with a minimum airflow setting exceeding 400 CFM need not comply. those are the big exhaust fans, the kitchen exhaust fans that we want to work. And I don't know why we're saying like, okay, well, you don't need to worry about it then. Those can be quiet too. You can do that. So just FYI, that's another thing that I'm like, I'm not really that big a fan of this. Multiple exhaust fans using one duct. Okay, so this is generally not a good idea, but they're saying that if you really have to do this, you can do that, but you need to not have separate dwelling units sharing one duct. So in a multifamily building and townhomes, you can't be combining this home over here with this family and then this home over here. Those can't combine, but within each family, you could combine them. If more than one exhaust fan in a single dwelling unit shares a common exhaust duct, each fan is equipped with a backdraft damper so that when one of the fans kicks on, it doesn't just send the polluted air into the next bathroom over instead of taking it all the way outside. That would be more convenient. It's the path of least resistance. If you're going to use single exhaust fan using multiple exhaust inlets, this would be what's called an inline fan or a manifold system where you've got all your bathrooms are sucked on by one exhaust fan in the attic. Then it needs to either be intended to run continuously or a system of one or more backdraft dampers shall be installed to make sure that they don't talk to each other when the fan is off. Supply ducts need to be either intended to run continuously or a system of one or more backdraft dampers shall be installed. So like if you don't have your fan, your continuous operation of your HVAC, then you need to make sure that that thing closes so it doesn't just let air come in anytime it wants to. And then operations and maintenance. Maintenance, now this is a big one. The dwelling unit ventilation system, including the equipment and other components, shall be maintained in accordance with an O&M manual, operations and maintenance manual. The manual needs to include detailed instructions for required maintenance of the specific ventilation systems that are in your home and the associated filters. And it's got to be given to the building owner or operator, like by the person who is handing that off, which would be the builder generally. So now there's going to have to be a lot of this like building a little binder, or a PDF probably would work fine. But anyway, you got to like put together a little manual on how this stuff works. No one is doing that right now. I don't even do that. So this is something that I think is a big opportunity for people to do better work. Because yeah, like how can you take care of something if you don't understand it? The climate data is here. You can see all this stuff. You guys should have access to that map. Feel free to pause and take a screenshot if you want to. And then other references of what this, and like again, this code is referencing other codes that you would need to know what's in there to really understand this. So the deeper you get into this, I think it just gets more and more interesting. So I hope that this has been interesting to stay all the way through to the end. I have no idea how long I've just been talking for, but I have a feeling this was a pretty nerdy video. Comment below if you have anything else to add or other questions about this kind of thing. We can have a discussion about it. Feel free to join our Patreon group, which is like where a lot of this stuff, getting into these details, just really comes up a lot. It's the best, in my opinion, the world's best ongoing building science conference. We meet twice a month and we just talk about like specific people's homes. We talk about specific policy decisions coming out. We talk about different technologies, and it's really, really fun. So that's at patreon.com/homediagnosistv. Like and subscribe. Tune in next time.